Thank you so much for joining us today for our panel on bringing legacy industrial technology to the future of flexible manufacturing with 5G. I'm Kelly Hill, Executive Editor of RCR Wireless News, and I'd like to introduce our panelists today. I'm joined by Dr. Alejandra Matamoros, who is Technology Manager at the Manufacturing Technology Center, or MTC, Andy McKenzie, Project Director for NextGWorks, and Dave Barrett, Principal Architect for Private Networks at BT. Welcome to all of you. Thank you so much for being here. All right, well, now that we've done introductions, we're going to run through some slides with Alejandra, and we will have a Q&A and a discussion after that presentation. So please, if you have questions, feel free to submit them through the user interface, and we will get to as many of them as we can. Dr. Matamoros, please go ahead.
Thanks, Kelly. Good evening, everyone. It's a pleasure to me to be today speaking about our experience in the MTC to date on bringing legacy industrial technology to the future of flexible manufacturing with 5G. And I want to start telling you a bit about who we are. So the Manufacturing Technology Center is based in the UK. We are an independent research and technology organization, part of a wider family of centers, which we call catapult centers, that were set to bridge the valley of death between academia and industry. We are part then of the high value manufacturing catapult family, and we are all distributed around the UK. We are an independent organization, so we are not tied to specific commercial industry or specific academic business, academic organization. And we were set actually to prove innovative manufacturing ideas where we develop processes and develop manufacturing system solutions with multiple technology domains and across different industrial sectors. And that spans from aerospace and defense all the way across agri-food and rail and infrastructure technologies. It's all about technology transformation. It's not only about creating new things, but it's deploying that transformation in the manufacturing industry. And we complement all of that activity around the commercial operations, the innovation domain with training and development of the skills of the future. So we have been growing throughout the years, and we are today an organization of more than 800 employees. So during the last decade, the MTC has been developing capability and resources to deliver the future of manufacturing to integrated digital systems. And we have been operating in three main scenarios, each of them with strategic aims led by our understanding of industrial requirements and high-value technology innovations. So the first one I want to mention is on rapid product and process development, where every day more we see requirements for virtualization, where we want to accelerate design and development of products, processes, services, factories, where we can minimize the risk and uncertainty and leverage the learning and automated analysis and data interpretation methods. The second scenario is smart and flexible manufacturing, very relevant to the topic today, where machine connectivity, these advanced forms of connectivity and data hosting that 5G is bringing to the table and edge computing, brings together opportunities for intelligent controls, robotics, and are leading to factories that will become self-aware, hyper-connected, and self-optimized. We believe that agility, resilience of production systems will be second in nature in manufacturing. And the third scenario is around in-service support and connected supply networks, where we're having to learn today to do many things in very different ways. It's particularly accelerated by the challenges brought by the COVID-19 pandemic and the wider challenges that we're facing today. A number of businesses in manufacturing has now an urgency to survive, and supply chain integration and collaboration, remote support and maintenance, distributed manufacturing are only example areas where digital can be massive aid to survival and transformation. And through digital systems integration, value will shift from the less tangible assets and will be redefined into that digital domain. So to start getting more in context, I want to make reference to what has been the typical challenge addressed in terms of connectivity in industry. And the typical limitations that we see when it comes to innovate in the digital domain. So core focus has been around overcoming the typical challenges on connectivity standards. Despite calling it standards, it's not actually universal. Manufacturing workshop environments are full of equipment with completely different type of technologies, and each of those technologies providing, if any, data in different formats or using different communication channels. In many cases, there is not even data available. So it's creating that access to the data so that it can actually get into the development of level of smartness and intelligence that we require in the systems. And security is a transversal challenge all across the manufacturing businesses, where not only the cybersecurity aspects from an IT perspective, but when it comes to the addition of how disruptive that could be to a production environment and how disruptive could be to the loss of or the violation of any IP concerns with respect to business is a significant challenge. So where there's been the less of an effort in terms of deploying connectivity in a manufacturing shop floor environment is risking anything related to network availability, anything with interference to the manufacturing processes led by interference in terms of the interaction between the different components of a production system, and its take coverage as well around that availability of communication services. So within the context of 5G, what's been happening in the MTC? So back in January 2021, we kickstarted our activities enabled by the manufacturing vertical of the West Midlands 5G Testbeds and Trial Programme in the UK, backed by the UK government, and a joint investment by BT, which is one of the largest telecom companies in the UK, and the MTC to deploy a co-creation space at the MTC environment to develop manufacturing use cases building on our extensive technical capability, meaning equipment, skills, and industry knowledge. So I'm going to show you today is then a result from a collaboration between BT, NextUWorks, also present today in the panel, and Spinout, which is a spin-out from a testbed program in the UK, and the West Midlands 5G program, which backed the work that we did at the MTC. So this is only the first milestone, and hopefully for many, many more to come that we achieved back in March this year. So the very first challenge that we set to ourselves was really to enable our main workshop at the MTC with a 5G private solution with edge computing capability that will allow us first to explore the capabilities of technology with a particular focus on the longer term offerings for autonomous control and robotics. And secondly, to develop skills and collaboration models so that we are ready to support 5G adoption, innovation, and development of industrial technologies, which is at the core of the things that we do at the MTC. So what have we done? So the network. BT has set at the MTC a future-proof standalone public network Nokia solution that is compliant with release 15 of the 5G network standards. The deployment is very simplified, very high level in terms of the different components that we have set up to enable the connectivity in the shop floor environment at the MTC, or we can enable then 5G use cases through specific dedicated modems connected to the internal environmental private network that we have provided by local radio antennas distributed across the specific areas and dedicated servers to provide those services on one side for the network itself, but also for the computational aspects. We did that in support with all the partners, including Nokia services in the UK. So the solution has a multi-access edge computing capability and operates on the Ofcom shared access band between 3.8 and 4.2 gigahertz. The network currently offers coverage within 2 workshop halls in the MTC, where we have plenty of machines, plenty of metallic structures that could cause interference to the network, and hence the network had to be optimized and retuned so we could serve the dedicated area where it was required. It gave a performance around the times of between 100 megabits per second uplink under a certain configuration, and it actually went up to 175 megabits per second uplink with a different configuration. And on the downlink, we got 691 megabits per second downlink, up to 788 megabits per second downlink with a different modem service. And we achieved a latency in between 10 and 15 milliseconds. The signal to noise ratio was between 18 to 21 decibels. Need to say there is an opportunity for improvement for this network operation, but it was sufficient for the experimental tests that we set ourselves to do at the MTC as this first milestone. So when it comes to that first milestone, actually, the delivery of a use case demonstrator was actually the development of an experimental use case, which is a 5G-enabled automation vision inspection system using this network solution. So what we wanted to do in this first milestone was to expose our engineers to the capabilities of the network and the key aspects around the infrastructure and the deployment of that connectivity within the use case, using those capabilities very well advertised from 5G, but also our capabilities to serve industry around shop floor connectivity, computer vision, automation, and robotics. So we set ourselves the objective to explore how private 5G and edge computing could be used to add both hardware and software modularity at the same time. So we have a bit of a representation here in the picture. You will get to see more in a moment. The transversal challenges that are associated to different manufacturing verticals, that is actually an inspection, assurance of the quality of the outcomes from production. So this is actually how we came about the definition of an automated vision inspection as our first use case demonstrator. So what does it mean in terms of automating product inspections? Let's look at these three facts. In many production environments, components of varied sizes and shapes are produced and need to be measured and checked to meet design tolerances. That's very transversal across industries. Traditional in-person inspections can be timely and are prone to human error and are not seamlessly recorded. So all these pull from more records around more digital records that can actually back up traceability of processes is actually driving a significant need around the records around quality aspects of the production processes as well. Automating inspection processes requires equipment to be sufficiently flexible and intelligent to meet on-time quality assurance needs and maximize utilization of costly inspection equipment, which take us to the process needs. So the use case was designed with example applications for inspecting metal brackets like the ones that we see in the picture that are used in construction sites. So there is a significant evolution happening now in terms of bringing construction processes much more closer to manufacturing practices. So we started adding some elements of that as part of the inspiration for the development of a system of the sort. So if we take as a baseline that the number of different manufactured parts of a complex assembly must be inspected each day before the assembly process actually continues or progresses, we start thinking about how we can go about supplying that efficiency around ensuring that those parts will actually meet the standards required during the assembly process. So that leads to some requirements in terms of what actually is needed for deploying a system of the sort. So an automated part transport solution is required to increase workshop efficiency. So that starts also addressing aspects that are related to the operational needs, but also from the business needs perspectives. Visual inspection of specific geometrical features of the parts manufactured in different production lines must be performed on each part to ensure compliance, and an automated inspection system solution is needed for consistency and traceability of the inspection process, which also responds to those operational and business needs. So the technical solution is a 5G-enabled automated system featuring automated logistics, robotics, and visual inspection. It's got these four main components as the elements of the solution. It's a system that's got an automated collection and delivery of parts features. It demonstrates robot-to-robot interoperability. It has to be 360-degree scanning so that it allows for that modularity in the physical aspects of the process, and offers automated inspection and execution using the edge as a platform. So basically what we designed was a system that through the 5G solution can actually execute all of these automated steps from the process and come out with an output that can actually support the manufacturing process itself to decide whether that part actually meets the purposes, meets the tolerances, and can actually continue to the next stage. That offers reassurance of quality for different inspection lines if we extrapolate the opportunities, and also support a better planning with respect to that quality assurance. It doesn't have to be part by part, but it allows for that definition of the strategy around the quality assurance. So when it comes to the system components and those requirements for the 5G solution, we have four main components as part of that system solution. Industrial mobile robotics, that was a near 200 platform that we use as part of the system, where we needed more reliability in terms of the connectivity of the platform to ensure there is shop-wide navigation and interoperability with other systems, and that robustness expected from 5G outlays between 5G itself and Wi-Fi. Automated robot inspection, we needed interoperability with other equipment and responsiveness for modular and intelligent automation. We use a robot arm, a universal robot 10, to perform the task, and we required interoperability with the MIA platform itself. Vision technology, where we had a management of high throughputs through wireless and remote computing. So we had advanced vision technology from the camera, from the hardware system itself, up to the software, implementing the inspection solution and controlling the assets of the system, and safety controls, which is shadowing here, because unfortunately we didn't achieve the requirements that we needed for safety. Not surprisingly, but that was that extra push that we wanted to do on the network. Well, we needed best latency for wireless safety controls, and the challenge was not only associated to the latency aspects, but the readiness of the technologies to actually respond to that. All supported by an edge control center from where we were running the applications for the system. So the integration of the use case implied the implementation of dedicated routers, enabling connectivity between industrial equipment, the 5G network, and the multi-access edge computing, the MEC server. And one of the greatest challenges that the team faced was around the implementation of the communication methods. It was not only a requirement for actually getting the data out there or up in the edge server, but also returning the data back to implement the automated process through interoperability all across the system. In terms of the outcomes, yes, the first question is that any better than the current solution? Well, everything started from implementing actually a baseline solution using hardwired Ethernet, industrial Ethernet, and Wi-Fi, the native Wi-Fi for the robotics platform. And the answer is yes, it's fairly equivalent. It's not any better at this time, at this point in time, but to a certain extent, it's just equivalent, technically speaking. However, the 5G-enabled demo provided us with a good initial evidence for high-value innovation by removing typical constraints of network connectivity and augmenting connectivity capabilities. So if we think not only about what is visible in terms of, okay, we need that robot system to perform this task, but think about what is in the background and how we can actually innovate with that, what happened in the background we can start thinking about scalability of this solution, where we can use more than one station or serve more than one production line. Modularity, where we can relocate the inspection system without the hassles of the physical, at least the physical connectivity equipment. Advanced computing, so that we can advance the quality of the analysis supporting that inspection system. Interoperability through the edge across the applications in particular. So it's not only the vision system, but all the other components that will start adding much more intelligence to the system. And that includes the control systems themselves. Remote controls, we're controlling from the edge. Anywhere monitoring, we can access information from any smart device through the edge support and further development. So further advancement that is not really possible through the baseline implementation. So bit of lessons learned, we ended up just classifying in the typical one, where we have, in terms of design and methods, high-level and low-level designs of both the network solution and industrial applications must go hand by hand. Also, it's not only about architecting the solutions, but identifying the technologies and or the methods to automate connectivity throughout the system and enable interoperability between devices where needed, which was the main hit that we faced during the project. In terms of 5G technology, it needs to be the right solution for the business needs. The 5G may not be the sole answer to the needs of an industrial sector, but it gives a significant reference to future-proof the technologies around smart manufacturing. Enabling connectivity in a shop floor environment as well is not yet plug and play, as we learned through the process as well, for many applications, and there is a need for enabling technologies to catch up with 5G connectivity. In terms of partnerships and collaboration, this is a must in innovation and adoption of new technologies. And I think all this digital era have been demonstrating the need for that robust development of the ecosystems to deliver what the ambition is around that, and the opportunities, of course. Sharing the risks, the costs, and the learnings of deployment, particularly when it comes to 5G, has been proven to be a more efficient way to push those boundaries. And I'm not speaking only from our own little experience with this first milestone, but what we have been seeing all around. Also, industrial digital technologies are a result of a technology ecosystem, which I briefly alluded to. And for instance, we had BT as an network provider, Nokia as a technology supplier, Nexiworks providing coordination between telecoms and our manufacturing world, and MTC designing and implementing the use case. When it comes to technical expertise, complementary skills are needed at this stage of the technology, more particularly, especially if we're referring to the plug and play challenge that is still there and may still there for quite a long time. For example, what we have in here is a combination of network expertise with MTC's IT, industrial connectivity, computer vision, and robotics expertise. And it's not only within the 5G domain. The wider smart manufacturing deployment actually requires this broader range of skills. Not surprisingly, and I think this is very common and generic, effective project planning and management is key to success, but that needs to happen all across those different teams involved in the delivery of a project of this sort. And in terms of the environment, consider where you are developing the system. Constraints such as security, which is core in manufacturing, and in manufacturing environment even much more strict because it also links to the safety policies, as well as environmental noise and coverage requirements, typical from such a challenged type of environments, and all of those being equally important together with the system specification when it comes to the functional requirements of the system. And just to finalize, my final remarks is that this is a journey, and I just wanted to tilt it a bit because it's a tilted journey. The value of 5G in manufacturing, we are seeing already, and this is a small example of that discrete use cases are demonstrating there is an opportunity there, but this opportunity needs to start scaling up at the same pace that we develop more advanced requirements for production processes. But at the end of the day, it will be through that wider vision, scalable vision around the actual deployment of smart and flexible factories with future-proof systems, so we have more integrated, hyper-connected systems all across the business, not only the shop floor, but all the external requirements associated to that. Thank you very much. That takes me to the end of my presentation.
All right, wonderful. Thank you so much, Alejandra. All right, so with that, let's dive into some discussion. Since Alejandra just gave us a very complete overview of the project and outcomes and lessons learned. Dave and Andy, I want to switch over and talk to you a little bit about, can you talk to us about some of the processes that went into putting this network together in terms of, radio planning, coordination, just sort of the technical aspects of actually putting this network in, making sure it covered the areas that it needed to cover and gave the performance that was expected of it. And Dave, maybe we can start with you.
Yeah, sure. So I think it all starts from customer requirements, really. So we start with the use cases. We start with the performance requirements, uplink, downlink, latency requirements. We look at the coverage area. We look at device numbers, and we build on that, really. And like you say, there's a lot of different aspects to that in terms of the amount of resilience we need to build into a system, the amount of radios we need to provide not only the coverage area that's required, but the capacity in that coverage area. That's really important. And as Alejandra kind of mentioned, the connectivity piece, the transport, is really, really critical, especially when you're joining and integrating legacy systems to kind of 5G solutions. It's quite a big chunk of the work and the complexity that we have to design around. Yeah, so those for me are the kind of key things that we take it from the use cases and build up from there. There's no point in building a 5G network for 5G's sake, right? It's got to absolutely meet the requirements.
Okay, and Andy, can you talk to us a little bit about NextGWorks' role in this and how you folks helped bring it all together in terms of both the planning part and the sort of technology conversations that had to happen?
Sure. So we're fortunate. We've worked with BT and others for quite a while on 5G, and we've built a number of networks. And I'd 100% echo what Dave said. You can't just build a 5G network. You have to understand why you're building it, where you're building it, what it has to do. And we were really keen to work in the beginning with Ali and her team to say, what are we trying to show? Why are we trying to show it? What does good look like? How will we know when we've done that? And then work backwards, saying, and I think it's worth saying as well that 5G is not a done deal. It's still developing. It's still changing. When we built this system, it was probably one of the first ones of its type ever deployed. So we were learning, and we were all learning together. And as Alejandra said, it was in the middle of COVID and things didn't always go to on plan. So our job was to try and manage that going through and make sure we achieved what we had to achieve as we went through. But yeah, that's why we were there. We were there to work, sit with BT and with MTC and say, we can do this now, or we can't quite do that now, and try and make sense of that.
Okay, so as someone who more typically covers commercial networks, system performance of 100 megabit uplink and 691 megabit downlink, latency of 10 to 15 milliseconds is pretty spectacular performance. I don't know if we can talk a little bit more about whether that was peak, average, and then is that exemplary of the kind of performance that's necessary for a 5G manufacturing network? Is that sort of, Alejandra, you mentioned that it was on sort of parity with existing Wi-Fi and wired networks. I guess I'm just trying to get a sense of, is that the level of performance that is generally going to be required for a manufacturing network? It's standalone release 15, obviously there's still a lot of 5G runway, but maybe you can talk a little bit about performance requirements.
Sure. So I won't be able to talk specifically about numbers, but when we think about upstreaming, we are talking about sharing that information that is generated in the source with the advanced computational systems that are required to provide those lower level systems with the required levels of intelligence. So streaming high definition data, either fixed images or video images, that's actually where the pool will start seeing much more often. The other thing worth mentioning is that this is an isolated use case. So that's the use of the pipeline for the single camera. So when we start scaling up, those requirements will actually start scaling up and making much more sense in terms of driving forward, achieving the actual performance characteristics that are being offered by the 5G standards.
Okay. Dave, any thoughts on performance? I mean, you know, it's 100 megabit uplink is a pretty big pipe.
Yeah, it's true, and again, coming back to Alejandra's point about doing it at scale, right? That's the challenge. And when we talk about speed and performance, so that is really good performance, but we've seen higher. As Andy mentioned, this is a little while ago we started on this, and BT's been involved for a few years now, private networks and developing them, and we're developing lots of areas in which we can increase performance and throughput, whether it's from radio frame kind of adaptation and looking into the future when we look at release kind of 16, 17, 18 to more feature enhancing, performance enhancing features. There's a lot to come with private networks, and you know, this was we were testing some quite intensive use cases here. We see a really vast range across kind of 5G use cases, from very, very low kind of telemetric type data requirements to very, very high. And that's one of the great things about 5G is the flexibility to be able to kind of provide dynamic quality of service for different use cases across different sites or same sites. It's pretty powerful.
Okay, Andy, any thoughts on performance?
Yeah, I mean, echo what's been said. I mean, I think one thing that to make it simple for people to understand is that what I'd call the public 5G is really a sort of massive internet, like a massively fast internet experience, and it's expected that you want to download and you want to consume. Whereas in industry, people want to, as Alejandra said, they want to serve information. So quite often the uplink is the constraint of what we want to do, and the downlink doesn't matter that much as long as it's as good as the uplink. So as Dave said, there's spectrum reasons and Ofcom reasons why things are configured how they are at the moment, but in time, it could be possible you could configure a network the other way around. You could have 600 megahertz, 600 megs uplink and 100 megs downlink if you needed to. That's where 5G is going, to give you that level of flexibility. It's not there now, can't be done right now, but that's the idea. Because if you're producing 4K video, you soon start to eat through bandwidth, and you're not that interested in downlinking. You're interested in serving information, so it's a different experience.
I want to ask sort of a big picture question. You know, Alejandra, as you were speaking, one of the things that really struck me is the amount of digitalization that has to that's sort of presupposed in order to move into this, you know, 5G enabled automated inspection. You know, and sort of if your processes aren't already digitalized to a certain extent, then it seems like it would be pretty challenging to jump straight from, you know, human-based inspections to, you know, computer vision-based inspections. You know, can you talk a little bit about the extent, are manufacturers, have they already digitalized all of these things, and so they're ready to be automated and move to you know, potentially 5G networks? You know, is there sort of a range of capabilities? Are there still a lot of manual processes that just need to be digitalized first before they can really move to automation? You know, what's sort of the state of things in terms of these legacy processes and, you know, and looking forward to 5G?
That's a very good question. Certainly, this is not the state of the art in manufacturing. This is the looking forward on what we can start looking as a much more of a common opportunities when you bring together automation and digital. I think those two streams are happening significantly still in parallel rather than happening together necessarily. There is a lot of legacy in manufacturing. And when we talk about legacy, it's not only the equipment, but the way of doing things in manufacturing. So there's a lot of brown fields that we still need to go about how to enable them with digital. And that's all that transformational piece around digital, but also in the adoption of automation and robotics. So I guess the short answer is no. The digital platform or the digital methods are not there yet necessarily, at least from this particular application perspective. But that's where we are aiming as providing exemplar references on what flexible manufacturing may look in the future when you bring together those two main domains. There are on the big OEMs, there are things that are actually happening on the smart factory front. But we think about SMEs, and the largest representation of manufacturing being SMEs is not necessarily where things are heading to as yet.
Okay. Andy, your thoughts on sort of digitalization and the state of things? It sounds like, you might have a broad view from working with, with multiple partners and industrial verticals on these sorts of things. What's your perspective on the state of digitalization?
So I think digitalization in terms of technology, one thing that we've been quite clear on is you need to win the accountants over. So there's really, although people might like to do cool and funky things, ultimately it needs to make sense in a business sense and give a return, and it needs to be returned in a reasonably controlled time frame. So we've seen discussions we've had with people where they've never realized that they might be able to use technology to do something better because they've never thought about it. They've just continued to make a slightly better mousetrap, so to speak. And we're trying to help them, saying, yes, but the state of technology now, particularly 5G, will allow you to do something in a different way. So don't just digitize your existing process, maybe change your process and do something new with it. So again, it has to pay its way. It's some of the early work we've done, and the work we did with BT, we had to find a solid use case that paid for itself to enable someone to take that technology leap and then gain the benefits. It'd be very hard to do it the other way around.
Okay. Dave, any perspective from BT on that question of the state of digitalization?
Yeah, I mean, I'd agree with everything that's just been said for sure. I guess from some of the perspectives we've had, it's it kind of adds to the importance of the end-to-end integration and design piece. It's, when we're talking about environments that aren't as digitized, OT and devices that are perhaps more legacy, that end-to-end integration and design piece becomes really critical to make sure that you have the performance and characteristics that you need across old and new, as it were.
Okay, great. One of the points that Alejandra made was really about, I think multiple aspects of planning and coordination, and sort of, I think, especially when it comes to technology, oftentimes that can mean something as simple as speaking the same language and sort of, understanding what KPIs will sort of get you the outcome that you want. Andy, I'm wondering if you can talk at all about sort of that process of bringing the involved parties together and, getting everybody on the same page, speaking the same language, because when you're dealing with both legacy technology and an entirely new cellular technology, it seems like there's a lot of potentially moving parts and pieces to bringing a holistic understanding to that. Next Works are not a manufacturer. I think BT wouldn't mind me saying they're not really a manufacturer either. Alejandra's team are very specialist manufacturers in a very specialist way, and we had to have pretty regular sessions where we said, I don't know what you mean exactly, because it wasn't necessarily clear to us why that might be really important to a manufacturer. I'm also aware that MTC is looking, as I said, to the future of manufacturing, and in the past, Next Works have been involved in a manufacturer who's running I'm going to say a proper production line.
it's a bit different in the MTC because it's reaching forward. I think the other challenge we faced as we went along is, as we said, the technology was changing, and the ability of what we could do and the availability of some hardware aspects meant that we had to have several plans and several ideas between us, which we had to share openly about how we would fill a gap if a gap appeared. So I guess the only way we in Next Works, and I know BT probably I'm sure they felt the same. We wanted Ali's KPIs to be successful as well. We were all driving to the same ultimate objective. And it was just a simple case of regular meetings. And it was, of course, a remote time of the world, because we couldn't really meet very often at all. And just to keep in touch and say, this is going okay, this is not going so well. And try and make sure we kept pressing forward and try and keep it on message. That's a bit of a woolly answer, but we really did it bit by bit, because otherwise we could have got horribly distracted into our own little silos, I feel.
Okay. Alejandra, any thoughts on sort of the conversations and coordination involved?
Yeah, certainly. Just echoing what Andy just said, the communication and the frequency of that communication and the open space to ask the questions that you don't understand, or just to double check that understanding is that common understanding was really a big learning throughout the process. At the beginning, it was an assumption that we were talking about the same things, but as we started going and finding out there were gaps in the communication, we started progressing with that. There was another particular learning in terms of who to communicate with. So there was a point where we had to get communication with also BT research, because the language in innovation versus service could actually be slightly different. And that actually opened up the resolution of one of the challenges that we were going through at those stages. So yes, communication and have that space, that safe space to actually have those discussions, because it's problem solving and trying to find that common solution to meet the KPIs.
Okay, Dave, any additional insights on this? You know, I'm sure that collaborations like this tend to inform other projects and making sure that things run smoothly.
Yeah, I don't think I've got anything further to add, really. I think I completely agree. Like constant collaboration, lots of whiteboarding and kind of knowledge transfer, especially, again, talk about the transport side, going over use cases, making sure, like you say, that we really are understanding each other and what's being asked,
Okay, well, maybe we can end with just focusing a little bit more on lessons learned, and if each of you could give me, what you think is sort of the biggest pitfalls to avoid that you would, recommend to our audience, as folks are thinking about connecting legacy technologies and looking at 5G, what are the real areas of focus that they need to do in order to avoid potential pain points? So Dave, I'm going to start with you.
Okay. So I guess wider learnings than just MTC, I would say, with the private network stuff we've done. From a technical point of view, I would say that never make any assumptions in terms of the use cases, and it comes back to what we were just saying about that clear communication and getting those requirements bang on. Visibility is everything. I think when you're putting in networks, the ability to see and make sure you've designed a network where you can see what's going on to enable you to be proactive and resolve things quickly is really, really important.
Okay.
And really clear kind of handover and acceptance. There's you can get networks that will go in and meet a base level of performance, but unless you're thorough and rigorous in what you accept as a complete solution, you're going to leave yourself open. So
okay, great. Yeah. Andy, what's your top point in terms of?
So yeah, for me, it's about requirements and about making sure you communicate it through. Just as Dave said, it's really important to keep it tracked along. Otherwise, you'll just get blown off course very, very quickly. This is new tech. It's easy to get distracted and rabbit hole. What is it you're trying to do? What does good look like? Are we there yet?
Okay. All right, Alejandra, your final thought on avoiding pain points.
Avoiding pain points. Ensure that you have the right skills in place to do the delivery, and move away from just having assumptions that you have the right team in place, and try to fill in those gaps as soon as possible. Involve the IT departments and IT experts as part of the delivery process as well. It's not only about bringing this new technology and developing those new solutions, it's ensuring that OT, IT convergence happens as smoothly as possible. Even if we are still in this innovation domain, the only way that we'll actually get this to land into real production spaces is having the right people with the buy-in, the right stakeholders with the right buy-in on that. And don't make assumptions that 5G is coming to replace like industrial connectivity, because that's not actually what is being sold.
Okay, wonderful. Thank you all so much for the time. We really appreciate it.
Thank
Thank you. Bye-bye.
Pleasure.
Cheers.